Hello students. Today we are going to learn about the fundamental concepts of organic chemical reactions. Organic molecule, when it reacts with an attacking reagent, it results in the formation of an intermediate which later on breaks down to form the main product and the byproducts. The way in which the reaction occurs is learned by what is called mechanism. Now, what are the fundamentals required for learning the organic mechanisms? That we will see here. The organic molecule that undergoes chemical reaction is known as the substrate. The substrate gets attacked by the attacking reagent to form the intermediate. The purpose of using the substrate molecule is that it is providing carbons for the formation of the new bond, while the other reactant, the attacking reagent, helps in formation of the new bond. During an organic reaction, a covalent bond is formed between two carbon atoms or a carbon and another atom. A sequential account of each steps describing the details of electronic movements, the energy involved in bond cleavage, etc. are dealt in reaction mechanism. Before moving on to the organic mechanisms, we must know what all fundamental things are required to learn it. The attacking reagents can be in the form of electrophiles or nucleophiles. Now we'll learn the difference between electrophiles and nucleophiles. Electrophiles are electron loving species. They may be either positively charged or neutral species. The main thing about the electrophiles is that they will have only sextet of electrons. Sextet means 6 electrons are present. As a result, it always has a tendency to attract a pair of electrons towards it. So it acts as a Lewis acid. Examples are H plus, Cl plus, Br plus, I plus, NO plus, R plus, and also certain radicals like R radical, carbenes with Cr2. Then we have molecules like SO3, BF3, BCl3, AlCl3, etc. The next type of reagent will be nucleophiles. So from the word itself, it is evident that it is nucleus loving species. So it will be either negatively charged or neutral in nature. They essentially have at least a pair of electrons. on it. So it acts as a Lewis base. Examples are hydride ions, chloride ions, bromide ions, BH4 negative, OR negative, SR negative, NH2 negative, CN negative, etc. In addition to that, certain molecules which are neutral like water, ammonia, amines, secondary amines, etc. can act as nucleophiles. The point to be noted here is that molecules or species which contain positive charge like H3O positive, NH4 positive, Na, Na plus and Ca2 plus do not act as electrophiles. They are never electrophiles as they have completed octet in them. So they cannot act as Lewis acids. First type of fission is called homolytic fission, where suppose you are taking a molecule AB with a bond in between. So AB is separated by a single covalent bond. If it is homolytic fission occurring, you find that breakage will happen to form two equal halves. So you know that a single covalent bond is formed by the sharing of a pair of electrons. If the electron owned by A is coming to A itself, and if B is retaining its lone electron, such a type of fission occurs, resulting in what is called homolysis. And homolysis results in two free radicals, A radical plus B free radical. These free radicals are odd electron species which are highly reactive in nature. Homolytic fission occurs in non-polar bonds and is favored by high temperature, ultraviolet radiations, and by the presence of free radical initiators. So what are the conditions here? You find that it occurs mainly in non-polar solvents or at high temperature or in the presence of ultraviolet radiations, and it can also happen in the presence of free radical initiators. The second type of reaction that happens is known as heterolytic fission. Heterolytic fission of a covalent bond results in the unequal distribution of electrons. You find that if A and B is separated by a covalent bond, and if B is more electronegative than A, then B pulls the electrons towards it and making it a cation A plus and an anion B negative. So A plus is a cation and B minus is an anion. So unequal distribution results in cation-anion formation. It usually occurs in the presence of polar solvents. And it usually occurs in polar covalent bonds. What do you understand by polar covalent bonds? When charge separation is there. Now you have understood the difference between electrophiles and nucleophiles. In the next part of the video, we will be learning how the electron starts moving in an organic mechanism. We'll conclude the fundamental concepts of organic reaction mechanisms in the next video. Thank you.